Okay, so on this video, we talk all about the plane areas. Okay, so plane areas bounded by the curves in Cartesian coordinates. Okay, so there are two methods for finding the areas bounded by curves, no, in Cartesian coordinates. So these are the using a vertical differential strip or vertical element of finding the area. Then the second is the using a horizontal differential strip or the horizontal elements for finding also the area. Okay, so in vertical strip, so this would be the graph. Okay, okay. So this will be the parabola or curves of the parabolic. So we have the vertical strips here. Uh, then here is our y, then dx. So therefore, the formula for vertical differential strip, that is area, where area is equals to the integral of y dx. And then while the horizontal differential strip, so it would be the strip is in horizontal. Okay, so this would be the x here, then the dy, then therefore the area is equals to the integral of x dy. Okay, so consider this example, problem number one. So probe into ways that the area of the parabolic segment is two-thirds the area of the circumscribing rectangle, no? Okay, this would be the illustration or the figure. Okay, so the parabola here is often to the right. Okay, so we have the indicate by A, B, C, D. Then the center is O. Then we have the distance between the origin of the Cartesian plane to this uh, latus rectum. Okay, or focus, or that is called the focus, no? So we have V here. Okay, so since the parabola is opens to the right, so we can take the equation or the standard equation of the parabola, no? Okay, so this would be the equation of the parabola. So y squared is equals to 4ax. Okay, so uh, or we can take the y equivalent, that is equals to the square root of 4ex. Okay, or that is equals to the 2 square root of ex. So take note that our x here, or that is equals to b. Okay, so therefore in this case, the since our x is equals to b, then the our coordinate of this point is b and 2 square root of ab. Okay, then we have the get the uh, vertical strips here. Okay, indicate the using a vertical strip again. Then this distance from this x-axis to this strip, that is our y. Then we're at our dx, no? Okay, so therefore dA is equals to 2y dx. Okay, symmetry of the parabola, no? Then another symmetry. So therefore, we can take the times 2, no? Okay. Since area here we can find, then also area here we can find. Then we have the 2 times 2 the square root of ex, then dx. Then integrate or simplify first. So we have, or extract the radical square root. Okay. So we have 2 times 2 is 4. Then the a to the power 1 half times the x to the power 1 half dx. Okay. So next, integrate. So the integral of dA, that is equals to 4e to the power 1 half, the integral of x to the power 1 half dx. Okay, so but the upper limit and lower limit is 0 to, from 0 to b here. Okay, so we can determine the upper and lower limit into 0 to v. Okay, or from 0 to b. So next, integrate this. So 4e to the power 1 half times x to the power 1 half plus 1 over 1 half plus 1. Okay, from 0 to b, no? Okay. So by the way, to integrate this, we use the simple power formula of the integration, no? Okay. So substitute the limits. Okay. So again, this would be for e to the power 1 half times 2/3 x to the power 3 over 2, and also a 8 over 3 e to the power 1 half quantity of the b to the power 3 over 2 minus 0 3 over 2. So therefore, the area of the parabolic segment, that is equals to 8 over 3 e to the power 1 half b to the power 3 over 2. Okay. So take note that this parabolic formula or the parabolic segment are needed to determine the shear and moment in the beams, especially in the strength of materials. Okay, so we can prove that the parabolic segment is two-thirds of the area of the circumscribing rectangle, no? Okay, so we can take this rectangle here from A, B, C, D. So that is our illustration of rectangle. So we will know that the rectangle, the formula of the rectangle, that is equals to the length times width. So we're length here, so that is our y. Then so substitute the value of equivalent y, which is 2 square root of ax, or also we can now substitute that x is equals to b here. So therefore 2 square root of a b. Then we have the x is equals to b, no? Okay. So therefore, the area of the rectangle, that is equals to 4 e to the power 1 half times b to the power 3 or 3 halves. Okay. We can prove that the area of the parabolic segment is equals to the 2/3 of the area of rectangle, no? Okay. So another solution with the use of the horizontal strip. Okay, considering also the same graph, we have the equation, no? Y squared is equals to 4ex. So in horizontal strip, so we can create this strip here. So naka-horizontal siya. Then okay, so in this case, the distance or the length of the strip v minus x. X here, we can get x equivalent into this equation. Okay, so again, this is our dy. The next, dE is equals to the quantity of v minus x dy. Okay. The next, the quantity of v minus y squared over 4e dy. Then integrate that, the integral of d, that is equals to the integral of the quantity of v minus y squared over 4e dy. Okay. So take note, the lower limit is or from 0 to 2 square root of EV. So this would be 2 quantity of, so since 2 or on this symmetry, we can get times 2 here. because we get this area, or this portion is we need to get this area, no? Then 2, substitute the upper limit, okay? So that is b times 2 square root of eb minus the quantity of 2 square root of eb to the power 3 over 12e. So simplify. 2 open brackets times the 2 e to the power 1 half b to the power 3 over 2 minus 8 e to the power 3 over 2 times b to the power 3 over 2 over 12e. Okay. So simplify 2 open bracket 2 to the power e to the power 1 half b to the power 3 halves minus 2 e to the power 1 half b to the power 3 halves over 3. So we can simplify, no, or to reduce lowest term, so which is 8 over 12, so that is 2/3. Okay, so since we have the same exponent which is the variable e and b, and also the same here, so we can minus. So area of the parabolic segment, that is equals to 2 open brackets times 4 e to the power 1 half b to the power 3 halves over 3, or this would be equals to the area of the rectangle. So therefore, the area of the parabolic segment, when you use the horizontal strip, it would be the same, no? So that is equals to 2/3 times the area of the circumscribing rectangle. Okay. So next, example number 2. Find the area bounded by the parabola x squared plus y plus 5 minus 6x and the x-axis. Solution. So we have the given of x squared plus y plus 5 is equals to 6. So first thing to do is to find the vertex of the parabola. Then to determine if it is whether opening to the right, opening to the left, opening up, or down. Okay. So we must recall the standard equation of the parabola and also the vertex, which is the formula, no? Or in terms of the following formulas. Okay. So we can equate y is equals to negative x squared plus 6x minus 5. Okay. So this would be used to determine the corresponding coordinates, no? So that we can graph or we can plot the curve in the Cartesian plane. Okay, so x squared minus xx is equals to the negative y minus 5. Okay. So in this case, we need to have the completing the square in order to have the roots. Okay. Or to get the roots of x, no? Okay. So since x squared minus x, so we can get the half of 6, that is 3, and we can square 3, so it would be 9. So therefore we can add here as 9, no? And also we can add here plus 9. Okay. So this would be, okay, x squared minus 6x plus 9 is equals to negative y minus 5 plus 9. So simplify. So this portion, which is the quantity of x minus 3 to the power 2, and that would be equals to negative y plus 4. Okay. Okay. So the quantity of x minus 3 to the power 2 is equals to negative quantity of y minus 4. Okay. So this would be the or our vertex here of the parabola is equals to 3 or positive 3 and positive 4. Okay. So next, we assume the values no for x and get the y values. Okay, so these are the following that I assume no those values of x, and then through this equation we get also the value of y. So if negative 1 uh, or our x is negative 1, so we can substitute here this equation to which is negative 1, so our corresponding values of uh, y, that is negative 12. Another is 0, then negative 5, then 1, then 0, 3, also 4, no? 5, then 0, then 6, negative 5. Okay, so these are corresponding coordinates. We can now plot the these coordinates, no? In order to determine the curve, okay, in the Cartesian plane. So we have our graph here. So take note that again the first coordinate intercept the y-axis, then the second coordinate, which is 1 and 0, intercept also the x-axis. Okay, and also another is x-axis also. So which is 5 and 0. We can now get the, or we can put here as the vertical strip. Okay, so since our the parabola is or opening down, so we get the vertical strips here. So this would be our y. Then we have the x here. The next, where dA is equals to y dx, then we can now integrate the integral of d, that is equals to the integral of the quantity of negative x squared plus 6x minus 5 dx. So take note, in order to determine the lower limits and the upper limits, okay, so as you can see the graph, so we can integrate or we can find the area of this, no? Okay, so from the start to 1 to 5, okay, so it is based on the x-axis. So in terms of the curve intercept, no? Okay, so next integrate. So we have the quantity of x cube over 3 plus 3x squared minus 5x. Then substitute the value of the upper and lower limits. Okay, so again we have the quantity of the negative 5 to the power 3 over 3 plus 3 quantity of 5 squared minus 5 times 5, then minus the negative quantity of 1 to the power 3 over 3, no? Plus 3 times 1, then minus 5 times 1, no? So where the area here, that is equals to 32 over 3 square units. To check by the use of the area of the parabolic segments, that is equals to the 2/3 of the area of the rectangle, no? Which is circumscribing rectangle. Okay, so to check this, our answer, so we can uh, get also the rectangle here. Okay, or indicate the rectangle here, no? Okay, so on this case, from 0 to 4, the distance of that is 4 units. Then another from 1 to 5, that is also 4 units. So therefore, by using this formula, then we get 2/3 times 4 times 4. So, and that would be the 32 over 3 square units. Okay. So, another problem. Find the area bounded by the parabola y squared is equals to 6x plus 36 and the y-axis. Okay. Solution. we have the given y squared is equals to 6x plus 36. Then where quantity of y minus 0 to the power 2 no is equals to 6 quantity of x plus 6. Then we have the vertex of the parabola, which is the negative 6 and 0. So therefore, if x is equals to 0 and this y is equals to or y squared is equals to 6 times 0, let's substitute the value of x, which is 0, plus 36, no? So y, that is equals to positive negative 6. So we have the same roots, or that would be uh, repeated roots, no? Okay. So this would be the corresponding coordinates in terms of the x and y values, no? So we have 0 and 6, negative 6 and 0, then 0 and negative 6. So we can plot in the Cartesian plane, or our graph is look like this. So the graph opening to the right. So from the this coordinates, so we have 0 and 6. So this point also 0 and negative 6, and this is our the vertex of the parabola, no? Negative 6 and 0. So we get here the we indicate here the vertical horizontal strips. Okay, so this would be the our horizontal strips, no? So from the distance here to this y-axis, no? So that is our x, then the y. Okay. So now dA is equals to negative x dy. Okay. So take note that our x here, okay, so that is equals to y squared minus 36 over 6. Okay. So the integral of dA, that is equals to the negative quantity of y squared minus 36 over 6 dy. Okay, so by the way, we indicate the negative x here since our area here uh, in this portion, no? So the area is, it would be this portion, no? So our x is considered as negative. Okay, that's why I put here negative x. Okay, so the integral of quantity of negative y squared over 6 plus 6 dy. So from our limit is from negative 6 to 6, no? Or positive 6. So that would be the our corresponding limits, no? Okay, so integrate this. So quantity of negative y cube over 18 plus 6y. Then substitute the corresponding limits. So it would be 6 negative 6 cube over 18 plus 6 times 6 minus the negative 6 to the power 3 over 18 plus 6 minus 6. Okay, so our area here, that would be equals to 48 square units. Okay, so to check this, we can create the rectangle here. So that would be circumscribing rectangle, no? So on this case, so the units, so we have the distance, no? Or the distance, which is 12 units here. And on another side is 6 units. So therefore, in checking, by the use of this formula, so it would be 2/3 times 12 times 6. So that is 48 square units. Okay. So next, example number 4, find the area bounded by the parabola x squared minus 4x plus y is equals to 0 and the line y is equals to x. Okay. So in this problem, we have the two given, no? Okay, so two given equation, which is the equation of the parabola. So another is the equation of the line. So which is the y is equals to x. Okay, so therefore we can find the first, no, the vertex of the parabola. Okay, so again equate the value y is equals to negative x squared plus 4x. Then x squared minus 4x is equals to negative y. Then we can now get the square. Okay, so half of the 4, that it would be 2, no? So square of 2, that would be 4. Okay, so therefore x squared minus 4x, then plus 4 here. And also we can plus 4, we need to plus 4 here for the another both sides, no? Okay, so that would be negative y plus 4. Then and finding the ano, so this would be the roots of this is repeated also, no? So or this is only one root but repeated roots, no? Okay, so we have quantity of x minus 2 to the power 2 is equals to negative quantity of y minus 4. Okay, so therefore the vertex here is 2 and 4. So fx is 0, so we can now substitute here our x. So therefore our y is equals to 0. When y is equals to 0, or fy is equals to 0, so therefore y is equals to negative x squared plus 4x. So or x squared is equals to 4x, then simplify, so x is equals to 4. So take note, if y is equals to 0, so x also is equals to 4, no? Okay, so this would be corresponding values of the x and y, no? Coordinates, which is 0, 0, 2, 4. So this is the 2, 4 is the vertex of the parabola, and another is 4 and 0. So we can now plot it to the Cartesian plane. Okay, so this would be the graph of this parabola. So since it would be, or the parabola is opening down. Okay, so in this case, this equation meets the origin, no? Which is start with 0 and 0. Also the equation of the line is 0, but the second is unknown. Okay, so this would be here our vertex, and here our corresponding intercept, no? From 4 to 0, which is x is 4, then y is 0. Okay, so to find these coordinate, or the corresponding intercept, which is the line, okay, so take note that y is equals to x, so therefore we can now substitute the what x here. Okay, so since this is y, then we change into x, so therefore x squared minus 4x plus x is equals to 0, or x squared minus 3x is equals to 0, simplify, where x is equals to 3, no? So therefore when x is equals to 3, so y also is equals to 3. Okay, so therefore here the corresponding the line intercept to the curve, or the coordinate, or the corresponding coordinates, okay, so that would be equals to 3 and 3. Our goal is to find this area, no? Okay, then we get the vertical strip here. So this would be this y sub 1 here is the distance, which is where the equation of the line from the x-axis, then another is the distance of where the curve of the parabola axis, no? That would be the distance, or what, that is y sub 2. So this is dx here. Then dE is equals to quantity of y sub 2 minus y sub 1 times dx. Integrate, the integral of dA is equals to the open bracket quantity of negative x squared plus 4x minus quantity of x dx. So take note, the limits is from 0 to this 3, no? Okay, here, because this would be our need to find, no, the area of this. That's why our lower limit is 0, then upper limit is 3. Okay, so okay, so next, simplify here. So the integral of quantity of negative x squared plus 3x dx, then the grade, then it would be the quantity of x cubed over 3 plus 3x squared over 2. Then substitute this corresponding value of limits. So that would be negative 3 to the power 3 over 3 plus 3 times 3 to the power 2 over 2. So the lower limit is automatic 0. So the final answer, or the area of this portion of the parabola, that would be equals to 9 over 2 square units.